Hello students, Professor Piggy here. Today we are talking about virtual private networks, so the wolf cannot exploit any weak corners of your network communication. A virtual private network, or VPN, provides remote access to a private network over a public network, most commonly the Internet, while protecting confidentiality and integrity of data in transit. VPNs create encrypted tunnels that allow trusted users and systems to communicate securely even when the underlying network is untrusted. This basic idea is the foundation upon which many newer secure access technologies are built. Organizations can implement VPNs using standard servers by enabling VPN services. In a Windows Server environment, administrators commonly use the remote access role. For traditional on-demand VPN connections, routing and remote access service, or RRAS, allows users to manually initiate VPN sessions when access to internal resources is required. For persistent connectivity, Microsoft provides DirectAccess within the remote access role. DirectAccess attempts to establish a secure connection automatically as soon as the client has Internet access, without requiring user interaction. This distinction matters for the exam because direct access represents an always-on model, while RRAS represents a user-initiated, session-based VPN. VPN servers may use one or two network interface cards. When two NICs are used, one connects to the Internet and is publicly reachable, while the other connects to the internal private network. This design allows the VPN server to act as a secure gateway, ensuring that all incoming traffic is inspected before it reaches internal systems, leaving the wolf pacing helplessly outside. As organizations scale, they often deploy VPN concentrators. A VPN concentrator is a dedicated device designed specifically to support VPN connections, including strong encryption, authentication, and support for many simultaneous clients. Because it is purpose-built, it can handle VPN workloads far more efficiently than a general-purpose server. VPN concentrators are commonly placed in a screened subnet, also called a demilitarized zone. A firewall between the Internet and the screened subnet forwards VPN traffic to the concentrator, while another firewall separates the screened subnet from the internal network. This layered design reduces attack surface and limits the damage if any single control fails. Remote access VPNs allow users to securely connect from remote locations. The VPN client first connects to the Internet through an Internet service provider and then establishes a secure tunnel to the VPN server using its public IP address. Before access is granted, the VPN server must authenticate the user. Authentication is commonly centralized using Remote Authentication Dial-In User Service, or RADIUS. VPN servers forward authentication requests to the RADIUS server, which often validates credentials against a directory service, such as Lightweight Directory Access Protocol. In Microsoft environments, this directory service is typically a domain controller. Internet Protocol Security, or IPsec, is one of the most common technologies used to secure VPN traffic. IPsec operates in tunnel mode or transport mode. VPNs use tunnel mode, which encrypts the entire IP packet, including headers and payload, preventing internal addressing from being exposed. Transport mode encrypts only the payload and leaves IP headers visible. This is suitable for internal private networks, but not for VPNs crossing public infrastructure. IPsec provides security through authentication header and encapsulating security payload. Authentication header uses IP protocol number 51 and provides authentication and integrity. Encapsulating security payload uses IP protocol number 50 and provides confidentiality, authentication, and integrity, making it the preferred choice for VPNs. These are IP protocol numbers, not port numbers, and that distinction is exam critical. IPsec relies on Internet Key Exchange, or IKE, which uses port 500 to authenticate peers and establish security associations. These security associations define how encryption keys are exchanged and how the secure tunnel is maintained. Once established, the tunnel protects data even if the wolf captures the traffic. Some VPNs use transport layer security instead of IPsec. Secure Socket Tunneling Protocol, or SSTP, uses TLS over port 443, allowing VPN traffic to traverse firewalls and network address translation devices more easily. This makes it useful when IPsec is blocked or impractical. Open-source solutions such as OpenVPN and OpenConnect also use TLS to create secure VPN tunnels. These solutions are flexible, widely supported, and compatible with many operating systems. Although the term SSL is still used, TLS is the secure standard in modern implementations. Administrators must choose between split tunneling and full tunneling. Split tunneling sends only private network traffic through the encrypted tunnel, while other traffic goes directly to the Internet. This improves performance, but increases risk if the endpoint is compromised. Full tunneling sends all traffic through the VPN tunnel. This adds latency and encryption overhead, but allows centralized inspection through security devices such as unified threat management systems. Many organizations accept the performance cost to gain stronger security controls. VPNs can also connect entire networks using a site-to-site model. In a site-to-site VPN, two VPN gateways maintain a secure tunnel between geographically separated networks. Users access remote resources transparently without manually establishing VPN connections. Some VPNs are configured as always on. In site-to-site deployments, the gateways maintain continuous connectivity or establish tunnels automatically when traffic is detected. In remote access scenarios, always-on VPNs connect as soon as the device reaches the Internet, protecting traffic on untrusted networks. Layer 2. Tunneling Protocol, or L2TP, is another tunneling protocol used with VPNs. L2TP does not provide encryption on its own, so it is commonly paired with IPsec. IPsec provides encryption and authentication, while L2TP handles tunneling. Some organizations use HTML5 VPN portals that allow users to connect through a web browser using TLS. These portals are resource-intensive because the browser handles protocol translation and session management. They are typically used for limited access scenarios, such as granting a consultant access to a specific internal system, like a voice-over-IP private branch exchange. Now we arrive at two modern concepts that expand and evolve traditional VPN ideas, and these are very important for your Security Plus exam. Software-defined wide area networking, or SD-WAN, is a technology that uses centralized software control to manage and optimize WAN connections across multiple sites. SD-WAN often includes encrypted tunnels similar to VPNs, but it adds intelligent path selection, performance optimization, and application-aware routing. With SD-WAN, traffic can dynamically choose the best available path based on latency, jitter, or packet loss, while still being encrypted. Security is often built in or layered on top, allowing organizations to replace complex site-to-site VPN meshes with centrally managed, policy-driven connectivity. From the wolf's perspective, the roads keep shifting, and every path remains guarded. Secure Access Service Edge, or SASE, takes this concept even further by combining secure network access with cloud-based security services. SASE integrates VPN-like access with technologies such as secure web gateways, cloud access security brokers, firewall as a service, and zero-trust network access. Instead of backhauling traffic to a central data center, users connect securely to cloud-based security enforcement points. SASE is designed for modern distributed workforces and cloud-first environments. It provides identity-based access, encrypted connections, and consistent security policies regardless of user location. On the exam, you should recognize SASE as a convergence of networking and security, extending traditional VPN concepts into the cloud. Remote access introduces risk, which is why organizations use Network Access Control, or NAC. NAC inspects clients to ensure they meet predefined health requirements before granting access. These checks often include firewall status, patch levels, and antivirus updates. Unhealthy clients can be isolated on a remediation network where they can update and become compliant. Once healthy, they may request access again. NAC can be used with VPN clients, wired networks, and wireless networks. NAC systems may use permanent agents, dissolvable agents, or agentless scanning. Permanent agents remain installed. Dissolvable agents run temporarily, and agentless NAC scans remotely without installing software. Each approach balances visibility and administrative effort. Authentication protocols control who is allowed through the gate. Password Authentication Protocol, or PAP, sends passwords in clear text and is insecure. Challenge Handshake Authentication Protocol, or CHAP, improves security by hashing a shared secret combined with a nonce. Centralized authentication is commonly provided by RRAS or TACACS+. RRAS uses UDP and encrypts only the password by default, but when paired with extensible authentication protocol methods such as PEAP or EAPTLS, it can encrypt the entire authentication session. TACACS+ uses TCP, encrypts the entire session by default, and supports multiple challenges and responses. RRAS and TACACS+ are AAA protocols because they provide authentication, authorization, and accounting. Authentication verifies identity, authorization determines access rights, and accounting records activity. Kerberos provides authentication and authorization but relies on other systems for accounting. For SY0-701, Domain 3.2, remember, classic VPNs use IPCC/TLS tunnels. SD-WAN optimizes WAN with smart routing plus security. SASE delivers it all from the cloud with zero trust elements. These concepts protect networks, users, and data while keeping the wolf permanently locked outside the fence. If this lesson helped you strengthen your exam readiness, remember to like and subscribe, oink.